class, we discussed one of the important topic which is known as shortest job first in preemptive, right? Shortest job first in preemptive. So in this case, we looked at the exercise which as follow. I will go straight to the exercise, and then you can be able to review what are the rules which we need to follow. The exercise which we had here was as follow. We had the following. We have process ID. We had the following things which as process ID. Let's take an example of this process ID. Let's take, this is an example of, we're going to have a process ID. For a minute. Just want to show you here, we have the process ID. All right, so let me try to draw one of the table as follow. Right, so all right, so I try to draw this table. If they become many, then I will reduce some of them. So we have process ID, which was P1, and we have arrival time of it, bus time. Arrival time was 2, and the bus time was 5. We had process 2, the arrival time was 1, and bus time was 2. Process 3, arrival time was 0, and the bus time was 3. But process P4, arrival time was 4, and bus time was 1. Let me try to remove this row here, because it's not where it is well written. And this row as well, right? Just want to make it more straight. So this is the exercise which we saw in our yesterday's class, right? In our yesterday's class. And this also is not needed. This also, we don't need this. This part is not needed. So in this mode, what do we need to check? What do we check in this mode? During this mode, we check the process which comes, which has the shortest bus time, right? We look at the process which has the shortest bus time. But you cannot start to check the bus time without looking the arrival time. Means arrival time, it comes from which state? It comes from the new state to the ready state. And then from ready state to the running time. So we are going to check the one which came first, which you have seen as a P3, right? As a P3. So keep this in your exercise, or keep that, in your part as we do the following exercise, right? So we are going to do this. I'm going to go next page so that we can be able to see what are the what are the new rules which we want to apply on this part which we have here. Hold a minute. So all right, so just want to go next page. Let me create the new page here. Okay, so in this page here, now we are going to start this way. We say at time is equal to 0, which process came? Process P3 arrived, or process P3 is in ready state, right? Is in ready state. So we draw the Gantt chart like this way. We draw the Gantt chart like this way, right? So here we have a 0 at the time 0, and P3 is start running, right? Is alive, P3 alive, or is in ready state, or start running, right? It is start to run, right? Next, at time which is equal to 1, what happened? What happened at the time is equal to 1? I may draw it this way, right? So we have to write all the possibility things which happened. Already P1, P3 is running, right? P3 has arrived. We have a P3 here. Now, before we decide which state to go or which state to start executing, we need to look to the arrival time and the burst time of the second process. Remember, we have the process in the previous one. Take a look on the previous one. The second one to came, or the second one to arrive, was P2, right? So at time 1 here, let me just put a draw here. At time 1, P2 arrives. P2 arrives. What happened? When a P2 arrives, but P3 is running. P3 is running. What do you do here? Now compare burst time of what? P2 and P3, right? You're going to compare the burst time of P2 and the P3. So once you compare this burst time, you will decide which one to execute. So when we compare, we take P2. What is the burst time for P2? It's 5, right? Yes, P2 burst time is 5. And the P3 is what? P3 is 3, right? P3 is 3. So since, is it correct? Yes. Is it correct, right? We check once again. The P3, the burst time, the burst time of P2 is not 5. It's not 5. It's not 5. The burst time of P2 is 2. It is 2. So since it is 2, what do you do here? You are going to consider P2 now. Means burst time P2 is 2, which is lesser than what? Than P3. So here I'll write the statement. Here we say put P3 in what? Put P3 in waiting queue. Waiting queue. We put P3 in waiting queue, and important rule here, update its burst time. So when you update burst time, you have to count, one time at a time, means 1 millisecond. So here, the Gantt chart for this one, which I'm going to write here, we're going to be at time 1, P3 suspended, P2 start executing, right? P2 start executing at this time. Now we come here at time is equal to 2. When a time is equal to 2, what will happen? When a time is equal to 2, P1 arrives, right? When a time is equal to 2, P1 arrives, correct? But P2 is running. Okay? P2 is what? Is running. and I put here and P3 is what? Is in waiting. So rules, what does the rule says here? The rule says that compare now, compare burst time of P1, P2, and P3, right? P1, P2, P3. And select, you have to select the one with the minimum burst time. Now, remember the burst time which we have there is what? We have a P1 is 5, P2 it is 2, and the P3 is what? 3 minus 1, which is equal to 2 because we are updated, right? We have updated. 3 minus 1, we take 3 minus 1, which is equal to 2, is 2. Now here is important rule. You see, the burst time of P2, of P2 and the P3, they are equal, right? Burst time of P2, P3, they are equal. So when they are equal, what do you do? When the burst time are equal, what do? You consider the process which has shortest alive time. Okay, I'll write here in this way. When here, I'll write here, when two processes, have same burst time, then select a process with with the shortest or minimum shortest arrival time. So among the two, which one we have? We have P3. I write here. I write process ID process P1, and I write process ID here P1, and this is gonna be arrival time, and it's gonna be burst time. I just want to write a small table here for you to see. And process 1 was 2, 5. Process 2 was 1, 2. Process 3, P3 was what? P3 was 0 and 3. Remember, we updated this one. After updating is gonna be 2. And we have also process 4, which is equal to 4 and 1. Okay, 4 and 1. So here we selected which process? We selected the process number 3 because it has the shortest burst time, right? I mean, shortest arrival time. So our draw will be like this. Our Gantt chart will be written like this way. Would it be 0? Here we have P3 was the first one. Here at the time 1, at this time 1, P2 came in. And at this time, when the time becomes 2, P2 is going to be suspended, and we select P3 again here. P3 is selected. So we don't have, here, we don't have a P3. Since there is no P3, I mean, we don't have a time 3, means at time there is, right here, there is no time which is equal to 3. Then what will happen? P3 continues, right? P3 is going to continue. P3 is going to continue, right? P3 is going to continue, right? Remember, P3 is going to continue. When the P3 continues here, look here, at a time 3, right? At a time 3 means let's say we consider one, right? We consider one at a time. So at time 3, when a P3 continues, when a P3 continues here, let's say P3 continues here, and the time which was given, yes, the P3 continues at the time 3 here. And remember, at this time 3, P3, it has to expire, right? It has to complete. So at this time right here, at a time 3, P3 finished or completed. You understand? P3 is what? P3 completed at a time 3. Now, from, P3 completed, right? P3 completed. Now, since we don't have this time 3 here, since there is no time 3 here, the P3 which we need to consider here, this P3 which we need to consider here, P3 time is not there, and we look to the next process, right? We look to the next process. What is the next process? Next process, we look at a time 4, right? It continues, but at a time 4 here, right? When it reaches to time 4, at a time 4, P4 arrives, all right, here at time is equal to 4. When a time is equal to 4, P3, P4, P4 arrives, right? P4 arrives. When a P4 arrives, now we compare the burst time of what? We compare the burst time of P4 and P2 and the P5. So check. P4 burst time is equal to 1. Look here, is equal to 1. And P2, the burst time is equal to what? P2, the burst time is equal to 1 because here was suspended. We need to update it. When a P2, suspended here, we need to update it. So the completion time for this one, the burst time for this was 1. And for P4, is also, hold a minute. For P2 was 1, and for P1, how many? P1 has not started, it's 5, right? So for the P1, hold a minute. Yes, for the P1 has not started, right? So at this time here, I wrote wrong here. I wrote wrongly here. Was it wrong? No, it was not wrong. It was not wrong. So at this time here, P2 will continue. P2 will resume, right? So we compare what? We compare this time P3 completed, and then there is another tie here. There is a tie, P4 and the P1, P4 and P2, P4 and P2, right? P4 and the P2. What will you check here? Check arrival time. Check arrival time. Arrival time P2 is 1, P4 is 4. So P2 will continue. And remember, it remains with only one time. So at time 4, at this time 4, here, at a time 4 here, right here, at a time 3, P3 completed. At time 4 here, at this time 4, P2 completed. At this time we write here at time 4, P4 arrived, and it has one time to execute, which means at time 5, P2 completed, right? P2 completed. So since this P2 completed at this time here, let me, write clear here. Write clear. Okay, so this was a 3. at time 4, P2 at time 4, P4 arrived, and the P2 was in waiting queue. P2 was in a waiting queue. P5 also arrived, right? I mean, P4 also arrived. Let me again read this part here. Just want to write this clear so you see it. If you have any question, please don't hesitate to text or to put in a comment section, or you text me directly, no problem, right? I'll repeat once again this part here. Here we say that P4 arrives with the bus time which is equal to 1, right? And arrival time is equal to 4. But remember, some processes are in waiting queue. What are those which are in waiting queue? We have P2 and P1. P2 with the bus time which is equal to 1 because we updated. P1 with the bus time which is equal to 5. It's a 5 because we did not enter into the process. So here we selected the P2. Why did we select P2? Because the arrival time and AT is equal to what? 1. So when we compare 1 is less, this is 1. When we compare 1 is less than 4, we select the P2, and the P2 have only one time to execute, means one bus time. So P2 completed. P2 completed. Now at this time, P2 completed means another time. Let's say here all the times are over. Look, from 0, 1, 2, they are over. Rule says that when all processes are over, important, this is important, please note it down. When all processes are over, then, when all processes are checked based on the arrival time, then the remaining parties, you need to complete each process based on their burst time. For example, the remaining one, we have P4, right? P4 and P1 are remaining. P4 has how many times for burst time? 1, right? P4 has 1. So will it be P4 will end at 6, right? The remaining one is only P1. The burst time is 5. Burst time is 5. So we take 6 plus 5, which is equal to 11. So here we have P1 will come here, take all this time till 11. Till what? Till 11. Till 11. All right, once again here, till 11. So now, completion time. I want you to write me completion time for these processes. This is your work, this is your assignment, this is your point. So you have to write me the completion time based on this Gantt chart. All right, thank you for watching and attention. If you have any question, please let me know. If you like it, you comment it. All right, thank you.